morning, everybody. Welcome to our topic, which is addressing automation needs in the vegetable industry. We have an excellent panel representing companies and producers around the world. And first I'll say my name is Chrissy Wozniak. I am the East Coast Sales Manager for Speedling Incorporated. We grow transplants across the U.S. The West Coast Sales Manager is in the room here somewhere as well. I'm also host of two podcasts, North American Ag Spotlight and What Color Is Your Tractor? And I'm VP of Communications for American Agri Women. So enough about me. I want to welcome David Paoli. He is founder and chairman of the Austchilli group, a vertically integrated agribusiness in Australia that's been serving multinational food and beverage companies for over 20 years. With a background in high-intensity vegetable growing and mechanical engineering, David's passion for innovation has positioned his company as a leader in the production of fresh chili and vegetable purees. His ability to implement cutting-edge business management systems has made his products highly sought after around the world. And next is, I'd like to welcome Thomas Beach, Managing Director of Autonomous Agri Solutions from the UK, with a degree in agriculture engineering and extensive experience working with some of the UK's largest fresh produce growers. Thomas and his co-founder are helping to lead the fourth agriculture revolution. Their company has introduced the Roboti autonomous robot to the UK, a breakthrough in lightweight, off-the-shelf agriculture machinery designed to streamline operations on farms. Thomas's vision for the future of agriculture will no doubt inspire us to think about the possibilities of robotics in the vegetable industry and production. Lastly, we're joined by Jennifer Skidgel-Clarke, the Executive Director of the California Leafy Greens Research Board. Jennifer brings extensive experience from both the regulatory and production sides of agriculture, having held key roles in food safety and regulatory compliance for major companies like Tanamura and Antley and Steinbeck Country Produce. With a career dedicated to improving leafy green production, labor practices, and food safety, Jennifer's insights into the challenges and advancements facing California's vegetable industry will provide critical perspective on how automation can enhance safety and productivity. So welcome to the panel. Sure. Better. Oh, that's loud. So Dave, is that too loud now? Okay. All right. So the cadence of this talk, I'm going to give them each speaker a few moments, and I have a specific question for each of them. And then after that, we're going to talk about vegetable production stages. So automation from seeding and transplants all the way to harvesting and packing. So that'd be the next 45 minutes, how we'll progress through this. So we're going to start with David. Given your experience in high-intensity vegetable growing and your vertically integrated approach, how have you implemented automation to improve your efficiency and your production in your companies?
Morning, everybody. So it was a journey of trying to make sure I didn't miss out on anything, and the old FOMO principle. But I travelled the world and identified what was relevant to what I wanted to do, and I love automation. I want to be not the first one to have it. That's called the bleeding edge, but the leading edge. So the next one to have it. Let someone else bleed first. And and then I bring a lot of this technology back to home. If we're talking farming, high intensity, I grow avocados and chilies, and back to the land is all about eliminating risk, because my contracts are with major retailers and exporters around the world, and they don't take prisoners. So if you have to deliver, you deliver, otherwise you don't get a second chance. So my focus is to have really product on time and in spec, and with that, sometimes humans let you down, so you have to bring in things that really give you real-time data to make decisions on. And so that was in the field, like automated irrigation. When is where we're almost finished now, that it'll be fully autonomous. So the plant will actually start up the irrigation pumps. Drone spraying, obviously quick and easy because we're working with regen farming now and identifying principles where we use less but produce more, and the consumer likes that type of strategy. And then in the facility, obviously robotics is where we're going, and a story there that was sort of, you got to keep it simple. You don't want to overcomplicate everything. You don't want to go to a lot of electronics that fail. And then in factories, we use a lot of sanitizers, and they are very corrosive. So you've got to think about connections and motors and sensors. So again, we try to keep it as simple as we can, but at the same time, we need to ensure that productivity, because I'm competing against the world. I'm here at this thing to benchmark myself against the rest of the world. I want to know what I don't know. So far, I haven't found anything that I don't know. So it was good because and I go back to my people and they say, "What did you find out?" And I said, "Nothing." And in a way, it's good because you're up with it. And I think once you get to that level, tech comes to you rather than you go to tech. So you get to that stage where you find it. Designed a robot, tried to get a robotics to pick and place. In COVID, people didn't want anyone touching their fruit, so it led itself to pre-packaging, so that there was nothing there where people go and pick a piece of fruit and then put it back, so that our growth in pre-packaging went through the roof. We were doing it manually, so then I had to automate it with pick and place robots, tried to get someone to do it, and $2 million and terms and conditions where we don't know whether we can do it. We not going to supply a safety program around it, and they own the IP, so you can know what I said to them. So when I went home, we bought 4 Omron robots, 4 Omron cameras. I put my people in place, and we built the whole thing for $600,000. And there's 4 robots now picking and placing. So again, sometimes you just got to look at a clearer path to go. And now that's set us up to do a lot more automation with other people. And it made us aware that it's not as scary as you think. So that's my experience in automating. And now we're trying to have a lot more, our guys now are fishing. And it's good because now they're on the boat fishing away on the weekend, but they get an alert on their phone to say that the pump hasn't started up or something like that. And they'll go boom, 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 boom. And so they're really working more than what you're paying them. But they enjoy it. They love it. So yeah, it's great.
Yeah, I love that, the way you outline how you're responding to the world's needs, and even quickly, if you've implemented that so fast, even since COVID. So that's really interesting. And then, Thomas, the UK is transitioning to the 4th agriculture revolution, where automation is really at the forefront of that. So can you explain where you're at and where you're going? Because that's exciting as well.
Yeah, definitely. Can you hear me? Hopefully you can shout if not. So, how did this all begin? I studied agricultural engineering, and all of our professors were telling me, "Tom, robots are the future. We're going to see robots in all farming systems." And I drove around the countryside, and there were no robots working. So I thought, there's a bit of a problem here. There's a missing link. What's going on? So I travelled to Germany to a large show similar to FIRA, but on a much bigger scale, Agri, and went there to investigate where these robots are and what I could buy. This was in 2019. And I came away from the first few halls really disappointed with what I'd seen until I stumbled upon the Agri robotics. And the point of difference there was their opening line. They said, "Tom, would you like to buy one of our machines?" And no one else had said that. And I thought that was really quite crazy that no one was trying to sell anything. They were just talking about what their product development was going to be and how they were going to get there. After a lot of trials and tribulations of trying to start a small business, we began importing that machine, and that was really the catalyst that got us going. So we have been focused on truly understanding the farmer's needs. I have a small family farm. I've worked with some of the large veg growers in the UK, so I understood the day-to-day practicalities of what it takes to make farming happen. And robots can nearly do that, but they can't always. So we work very, very closely with the manufacturers to be part of the development loop and to do the final elements of product testing. We work very, very closely with the farmers to understand what are their pain points, what are the challenges that need to be solved, and where are the low-hanging fruits, so we can start there and develop into complexity. And then how do we make that happen in, most importantly, a commercially viable sense? A lot of robotics is very expensive, so as part of that, we have started a RAS service, Robot as a Service, and this allows us to really de-risk it for the grower. So we can deliver machinery onto farm that we staff, provide the logistics for, set up, provide all of the hardware, and I'm either delivering a clean field with no weeds, or I'm delivering a seeded field. They don't care what the robot is, that doesn't matter. It's just a tool to do the job in the most efficient, most precise way. And that leads on to our greater ambition of becoming a dealer that can travel the world and find the best technology and deploy it in the right way to our farms. And every time we've done one of these robot as a service contracts, we end up selling the machine back to the farmer at the end of it, and they can use it themselves now that it is truly proven, not just in a 3-minute video on YouTube, but in their real commercial environment.
Yeah, I really like your mindset with that. Especially in the last 10 years, we've seen a lot of ideas, we've seen a lot of research coming out of universities, some of these really cool, innovative things that are being made and produced, but without it positively impacting
worth anything.
the
So I really like your
producer
mindset
and
there.
making
So
profit.
I've got an expression I like to use that's
It's
what
not
we
really
do.
worth
We do
anything.
nerd
So I really like your
interfacing.
mindset there.
I've got an expression I like to use that's what we do. We do nerd interfacing. Farming. So you've got all these genius engineers, these nerds, they want the really great fly and but they don't understand farming. You've got these great farmers that want to innovate, but they want the robots to jump in the middle of that. We perform magic and don't understand what's nearly there, but you need to focus on this really. So we jump in the middle of that. We can focus the engineers and say, you're nearly there, but you need to focus on this really, really simple network that you're developing. Don't focus on this that adds no value to the farm. Phenomenal piece of AI, and then it's neural network that you're developing. But then we can go back to the grower as well and manage expectations and say, we can't do everything. Robots won't do everything now. They may do in the future. But let's focus on what actually works and what really makes a difference to your farming practice and fits with your system.
Right, excellent, thank you. And Jennifer, your role at California Leafy Greens, tell us what you do and then how you see automation playing a role in improving food safety, pest management, plant breeding, and particularly in the harvesting, processing stages, and what are some key areas where automation can help reduce food safety risks as well?
Am I too loud? It feels loud. It feels very loud. So I'm with the Leafy Greens Research Board, and what the Research Board does is, fund research, right? And it is a mandatory assessment, so all Leafy Green handlers pay into this program, and then we use that money to go forward and fund research with USDA, UC Davis, UC A&R, our farm advisors are a big piece of that. I know I saw one in here earlier. And I think in terms of technology and automation, the role of the Leafy Greens Research Board is to really, in my mind, and kind of what Thomas had just said, really help connect the nerds, the tech nerds, with our farmers. And I really like what the board has done to help some of our farm advisors and our UC specialists work with these different tech companies to help them make their equipment better. Really get out into the field, be able to understand what the growers' needs are, and work through issues. We've had, I think, a lot of great success in terms of some of the weeding technology that's out there. If we're thinking about food safety, I saw your question ahead of time, and I had to really think about that. I don't see automation necessarily being any kind of piece of equipment that would help in the food safety world. I think one thing it's important for everyone that's creating equipment is to just be very cognizant of food safety issues. Think about how is that equipment going to be sanitized? Can it hold up to pressure washing? Can it hold up to sanitizers? Are there nooks and crannies in that equipment where you're going to have plant pathogens hunker down and survive? Think about biofilms. I think it's really important to get educated on the food safety risks, because those are real true risks. Also in the food safety world, though, we have a lot of checks and balances and processes, right? So if there is a way to help automate some of those processes and help take human error out of that would be incredibly useful. There's a lot of auditing, a lot of paperwork trails, a lot of quality controls in place, and automating some of those processes might be beneficial going forward. Also breeding, and we were talking about this a little bit before we all sat down, but we all know we need to breed crops to work with harvest automation, but the research board's also looking at breeding crops for food safety. And so there's just huge innovations in plant breeding. I don't know if we have plant breeders here in the audience, but some of that technology is moving so fast and it's so amazing. So if we can really look at plants and understand why pathogens grow on the plants and what kind of plants we need, whether it's the microbiome on the plant or it's leaf exudates that are helping make a surface hostile to human pathogens, that's really important. And we are seeing some really neat results looking at that. We weren't sure if that was a thing, but we found out it is a thing, so we're really excited about that kind of work.
Yeah, that's good, and I like the angle too. And here in this audience and on this property right now at this show, there are a lot of manufacturers. So I like how you spoke to manufacturers. That might not be something that a lot of the people who build the equipment are thinking of is food safety at the end of it. So another thing, good thing to keep in mind. So we'll shift now to the vegetable growing process and the stages. And starting with direct seeding and greenhouse transplants, how are automation technologies shaping decisions between direct seeding and greenhouse transplant in different regions, different areas of the world? So whoever would like to go first.
Well, I can start if you'd like. So I think there are a couple of things there. We've been, with UK Contingency, we've been driving around seeing a lot of the farming practices in California over the last few days, with the Australians as well. It's different in different places. And when you look at it from a technology point of view, the right tech to do a high-speed automated plant tech transplanter will not necessarily work for all crops and all plant types in the UK. A Stanhay precision seed drill can be really, really great for carrots, but maybe in certain soil types there are different systems that need to work better there. So I think what I really see as the best approach is there isn't going to be a silver bullet for this. How can we find the right tech for the right farmer and really focus on the detail of the farming practice on that field? Before we sell a machine, before we talk about doing anything, I want to be on your farm, in the field, going with you, looking at what you're doing today. Because if you're a large business today, you're doing something right. We're not coming here as engineers to tell you you need to change everything. We need to learn from what you're doing and gain those micro efficiencies to keep it viable.
So in our situation, we use a lot of transplants because we're planting in plastic mulch. So we have the drip tube and then plastic mulch, and then we have offset 2 rows beside it. So in our situation, we can't use seeds. If we put seeds in there, the germination mightn't be right. And because I've got a very tight schedule of supplying and a tight timeline, the less risk I take trying to get a seed to germinate to drop in a transplant. I know that by my growing degree days, I can have that product ready for dispatch as when the customer wants it. So in our situation, it probably doesn't. The rest of my Australian delegation, they're doing all the other stuff, and they're the same. Some are direct seeding, so it's horses for courses. I don't think there's, as Tom said, there's not one silver bullet that's going to make a difference to that. Someone will take it up, and others, well, we won't, because there's nothing advantageous to us. And the take planter there, well, it doesn't plant into plastic. So the theory is great, principle is great, idea is great, but it just won't interface with our current production. And I think if we do go to seed, I think we need to go back to seed germination vitality. In other words, a seed that, again, goes back to my breeding thing, that we make sure that the plant breeders have got a lot of energy in that seed, so it can handle a little bit too dry, a little bit too hot, a little bit too cold, so that we get 100% germination. Because the problem is, if you start shit, you end up with shit, you know the whole story. So we got to get it right the first time. Yeah.
Yeah, and I thought on that too. I feel like harvest is the holy grail, but really to get to a point where you're harvesting mechanically or using automation, you really do need to start at the very beginning, right, with your field prep and your seed and your spacing. So, you know, a grower really has to start thinking about automation, whatever they're going to use during that growing process. Really has to start thinking about the seed, the transplant, the bed prep, and like what's already been said, it really depends on crop, right? What works and what doesn't work.
Right. Yeah. And so, what advancements in automation are improving planting precision in the field?
Yeah, so there's really a lot happening in this space, and it's really exciting. From a transplanting world and planting half-established crops, it's about reducing labour in the field. And that's really where the cost saving is. And the plant tape's a great example outside. There are others, such as the TTS transplanter, the Agri planter, and they're really starting to prove they can work at speed in a range of different conditions, and that's really cool. But on the wider point, as we go through this growing system, it's really important to, if you're developing machinery, not to focus on your little niche, but to look at it holistically and say, okay, how does my sprayer fit into this system? How does my weeder fit into this system? How does my harvester fit into this system? So you're designing the tech not just to solve the problem, but actually work with everything else around it in that farming system.
Right.
Yeah, no, I agree with Tom. I don't think there's much more than that. There's a point where no matter what you do, it doesn't give you that extra return on investment. So, you know, guys are pretty clever now. They know the total population in the field to give them their max production. Once they go under that, it drops, and over that. So it's all about precision and what you're doing. So if mechanical is doing it, why change? If it's not broken, don't fix it. So.
Anything to add?
Well, just thinking about all systems working together, the speakers before were talking about spray technology, and drones were mentioned. You know, the hard part about using something like a drone is you have to map the field before you can use it. And even some of the other technologies around spraying or weeding and thinning, mapping fields first. So if we can do that when we're planting and get a field mapped so that we can continue to use that map for all of the other processes along the way, I think that would be an incredible time-saving and useful technology.
Yeah, just following on from that as well, I think the compute we have available at a very reasonable price now has unlocked a lot of edge computing, so we no longer, we do sometimes, but it depends on the situation, we no longer need to focus on these big data sets. Sometimes we can make in-field decisions at a per plant level, and that can be really beneficial, and that can unlock different technologies to be used in different systems. That being said, like what you said earlier, if it's not broken, don't fix it, but really understand why you do everything. Every operation in the field, we think, what value is this adding? Why am I doing it? If we're going to buy a perfect laser weeder, that might be the best thing to do it, but actually what value do I get from having some weeds in the crop, or a few weeds, or a lot of weeds? There's going to be a point where there's an asymptote on that graph that actually the cost-benefit analysis doesn't work, and sometimes a lower level of tech is still sufficient to get the overall economics right in your field.
Yeah, great points. And now, so we've got, you know, plant in the ground, and there's a bunch of time now before harvest, and there's a lot of things that have to happen there, from inputs that have to get put on for weed management. What are some ways that automation can help that period? And David, I know before you talked about some crop health sensing. Can you speak to that a little bit?
Yeah, well, from the Australian delegation, we feel that real-time data is where we need to be. So, you know, we do the old traditional tissue tests, sap tests, things like that, but by the time it comes back from the lab, veggies grow quick, and that point has already moved by the time our analyses come back. So if we can get sensors that are, whether it's a drone, whether it's with a little buggy or whatever, that reflection or that reflection back, because we know now insects are attracted to different colours, and you have a different colour, you have a different nitrate level in your leaf, it'll attract your pests. You have a different nitrate, it'll fly straight over it and go to there. So we already know this, so we need to have those sensors that tell us, hey, your nitrate colour is too far on this side of the scale, we need to bring it back here so the aphids keep flying over and go to other people's and wipe them out, hopefully. then the price goes up. But that is easy, and if we put that sensor on anything, I think that gives us real-time data, and then when our SAP does come back, we can ground truth that, how was it really, and then we can make decisions much quicker. So sensors like that to us, both for irrigation and for crop health, I think will make us, and at the end of the day, the end of the game is our costs are going up, so if we don't produce high yielding returns in quality as a pack out and volume, you're behind the game. I heard here the other day that celery, the guys are losing $5 a box because there's so much on the market, and you know, so that's where we got to sort of stay away from. And yeah, so any technology in that, so ours was crop health sensors, irrigation sensors, tied up with irrigation is so important. If you miss a irrigation or over, you trigger a stress point. Once you trigger a stress point, you trigger a pest and disease point. So you're beyond the 8 ball. So what you need is these sensors in real-time data with weather modelling and predictions from weather stations to know what's going to happen 5, 10, 20 days ahead, and then you can manage your system so you don't go into that stress point, and that stress point you can't come back from. So I think weather-related irrigation sensors and crop health sensors is something that we'd like to see a lot more done, and it's there. It's just relating the colour or the reflection or whatever. I'm not the techo here. Back to a database, and then that database with AI, and then the AI will tell you, no, the tone's got to be a little bit more there because that's where the problem hits. So.
Yeah, and we've got to think about how do we practically deploy this, how do we make it work? You walk around FIRA and it's just fantastic, the range and versatility of different machines. But there's a big point around autonomy and automation. So sometimes it's great to automate processes because we can kick the labour out of it. But actually, full autonomy, self-driving vehicles, drones, the work on their own has huge value when we're combining them with IoT sensors and putting them in the field so that we can get consistent data points. We can really have a detailed per plant analysis, but really start to do it in a practical way for the farmer, because they don't want to go and take out a handheld sensor and walk around 10,000 hectares of lettuce. You know, we've got to automate this and get it working so we can get that data consistently and cheaply and well, and then make actionable insights from the data we generate.
And Jennifer, what are you seeing in California here?
Well, I think too, from thinking about the research perspective on this, all of this technology is really fascinating, and not to disparage any researcher, but I just don't see them coming up with maybe the hardware to get these kinds of things done. But I think researchers are perfectly placed, and are like farm advisors. I always beat the drum about farm advisors and how important they are, but they're perfectly placed to work with these tech companies to really help translate all of that into the field and figure out what is it that the grower really needs. And growers are so busy, right? They don't have time to help vet every piece of equipment or every technology with every tech company that's out there, but using those researchers to help do that, and especially farm advisors who are like boots on the ground, is, I think, really important.
Right, yeah, and listening to the three of you, it just makes me think of, imagine a farmer from 100 years ago was listening to this. It's pretty amazing, and we need to really absorb how far we've come in such a short time, right? Yeah, it's really amazing.
Just a couple of clear examples of some of the things that we've been doing in Europe. Right now, I don't know what the time difference is at the moment, but a few hours ago we were planting spinach fully autonomously in a field in Spain. This is real. It's happening and it works. And this is something that you can get on board with. And there are companies like ours at Autonomous Agri Solutions, and plenty around there, that really do get the detail and want to make it work. We need the buy-in from the farmers now to tell us what we're doing wrong so we can make it better. And without people taking these big steps forward, these leaps of faith, these capital purchases to make the whole system happening, we can start to stagnate and reach a bit of a wall with it, and we need to break through that.
Mm-hmm. I think too, if we're thinking about labor, and I know in Australia you're dealing with labor, and over in the UK too, just like California, right? We're seeing people really age out of farming and not seeing a lot of new people come back in. So thinking about autonomous vehicles is pretty amazing, right? Tractor drivers are pretty hard to find, and good tractor drivers even harder to find. So getting even our younger workforce really excited about how how far farming has come, and it's not the same as it was 100 years ago, and there's so much tech, there's so much innovation. It's really an exciting time to really talk about how important it is to feed the world and get younger people interested, and even upskill some of our current workforce to find those that are really interested in it, willing to learn, capable to learn, and create these amazing jobs for people. It's pretty neat. I was talking to someone too who's saying, now they're not looking for maybe ag degrees, they're looking for computer science degrees, because now we've got people working for farmers that are really sitting in front of lots of computers managing a lot of systems. Like, that is not the way we pictured farming, right? 15, 20 years ago. So it is moving fast.
Yeah, absolutely. David, anything to add to that?
Yeah, I only wish I was 50 years younger, because I think agriculture is so exciting now. It's just at that point where it's going to take off, And I say to my people, I say, I want to put food in space. Well, they're redocking rockets now, and there'll be colonies out there, and we've got to think that far ahead. We've got to be ready. And I said to my guys, before I go out, I want my stuff to be on that rocket to the Mars colony.
Wow.
And I think that's how we've got to think, and it's not far off. He landed that rocket back, it came back, sat there, and I'm ready to go off again. So it's not far away. And it's agriculture is in the box seat to go from there to there. But we're using old, like regenerative farming now. We're starting to understand the science of less is more. But when you add the scientific attachment to it, you know why, and you know how, and you know when. So it's giddy up.
Looking at robotics, I play with robots in the field every day. It is great fun. But robots don't add any value to a farmer. The tool on the back of the robot, the mode of action, that is the only thing that makes a difference. So we've got to get the robots right, and we've got to focus on that, and they have to be robust, functional, cover the area. But actually, that's almost a side detail, and we need to be careful not to fall into a trap to get distracted by the latest drone. We still need to focus on what are we actually doing, what's our reason for being in the field here, and how can we do that better?
Right, exactly. And moving on now to the stage of harvesting. What are you seeing as breakthroughs in harvesting technology, and how are they developing the differences between different types of crops? There's a big difference between a carrot, for example, and a pumpkin, right? So how is that being approached?
Well, I just want to put a little plug in. Our company, in collaboration with a couple of others, I believe was the first in the world to do a fully autonomous broccoli harvest. And it didn't work. It was really cool, and there's a great 30-second video of it, and it looks amazing. But at this point, it was still cheaper to harvest broccoli in a field with people. So there is loads and loads of work going on. We are so close, and it is the golden goose, the holy grail of ag tech, to be able to eliminate harvest labour whilst maintaining the quality, the speed, and the cost. We're not just there yet, but I tell you what, that's going to be the next breakthrough, and we're really, really close.
So I think it's a bigger picture than just trying to develop a robot to pick or automation. I think we need to go back to basics. We need to design the plant canopy, the plant structure, the leaf structure, the branches, everything to suit almost automation. And I think until we get there, it's very difficult to get that to do a job that, holy hell, how am I going to do that? So there's a lot in it. And as I said, plant breeding is something that we have to bring in the world of innovation. And breeders are trying to breed for a lot of taste and colour and disease resistance and all that sort of stuff. But I think we need now to deliver to innovation, to adopt autonomy, and to be resilient in as soon as that robotic arm goes in there, and the detachment from the plant itself. That you can use chemicals to do that, but it's got to be in a way that it's almost at that ripe stage, it's almost ready to fall off the calyx so that you don't damage it. And we seen an apple harvester there the other day, and they had to go and snip the stem by hand. So there's things there, well, genetically, can we have the stem fall out of the apple, but not break the surface of the skin so that disease goes in? So there's a lot to automation and in robotic picking or automated picking, but I think the one thing that is common across all of our crops is the vision system. That vision system, where it is, what to pick, when to pick, I think that is the key, that lines us all together, and then on top of that goes the different manipulators and the different platforms.
Great points.
Right. Yeah, I think it's important to recognize where we've got commonality that we can work on across the board, across commodities. I will say we're lucky in the leafy green space, right? That crop moves very fast. It's not a permanent crop, but even that said, plant breeding takes a very long time. So I'm always trying to put a plug in, and I hope kind of our newer, younger generation is really excited about technology as a whole. So, moving away from this idea of GMOs, but really looking at, genetic techniques and how can we use gene editing to get there faster. I mean, it's important for automation, and it's important for disease management. We haven't yet talked necessarily about pesticides. You asked me that at the beginning, but in California and probably through most nations, we're looking at losing pesticides and moving more towards organics. But how can we keep some of our current tools and our current chemistries is really important as we wait for breeding to catch up and find us those plants that are resistant to certain diseases, certain pests. That said, diseases and pests always break resistance, so it's a constant ongoing battle. But I think using technology to help get us there faster, using it to do more precision spraying when we are using pesticides will be important to reduce that environmental load. And those are really great stories, too, that the industry can tell.
Definitely.
Joe, just going back a bit to harvesting again, something to make really clear is that we don't need to jump from step 1, where we are today with people in the field cutting into boxes, to step 5, 10, 100. We can do this in stages, and there really is a place for high quality mechanization as opposed to automation. So if we look at, over the last 50 years, how the developments in root crop harvesting have gone, how highly mechanized that is, that's a really great story. And I think there are other ways where we don't necessarily need to go to a 6 degrees of freedom robotic arm that can move around and pick a lettuce or pick a broccoli. How can we begin to mechanize that in a way that works well? And I know there are companies in the UK, Germany, Spain, and out here in California that are really, really doing these, everything from cobots to mechanized harvest that then still has a human in the loop, but supports that to make it much more efficient and much more cost effective. So I think that we can get there in stages, and we don't need to solve all the problems at once. And to the companies that are shooting for the stars that I think need to exist and still need to happen, they still need to make sure they get that holistic view of the cropping system, because one of the big challenges is the architecture of our field, the way we're in beds or rows. How do we manage to fit all of this into a field and pick and get it out again, and make that work in a sensible fashion?
Yeah, those are great points. And then to that, what are each of you seeing in your respective areas where you live and work, the adoption of this technology? And also, what is your advice to producers who are thinking about jumping in but are a little bit wary of, the cost or, wondering about benefit, right?
So Australia is well advanced in technology. We're right up there with, I said before, what did I learn or see here? Not much that I didn't know of. And there's a pocket of suppliers or growers that are way up there. And they're good and they're smart. And Australia adopts technology very quickly, very easily. They're not scared to it. So I think we're waiting for it. And then you'll get the show and tell. You've got the guy over the fence that'll look at it and say, oh. And then once he sees that thing go up and down, oh. And then eventually, where do you buy that from? So, once it's proven, it goes there. And we're smart people. We do the ROI. If it's not within 2 years, we'll wait till it comes down to 2 years. Because the first adopters, as I said, are the bleeders, and then the second one are the leaders. So you've got to wait for that time. The other thing that, while I'm on the plug for the Aussies, is when the tech guys come there, we're not America. We're not massive broadacre. We're intensive, but we're in a small area, and so the field is smaller, but it's concentrated. So it's a different environment. So my suggestion to any of the tech guys who are thinking that, come and talk to us, come and see us, ask us what we really want, and specifically work with us from the before concept, then work through the concept and the development, so that when we put it in the field, it's almost ready. It's only then Mark 1, Mark 2, just a slight change. But yeah, that was the notes. What we really like would be a robot here at the fair serving coffee
I can't argue with you.
instead of humans, so make it quicker. And the other thing the guys wanted was beer delivery, an esky with wheels that they said beer, and it came to it with the esky open. So that was the Australian point of view.
That's innovation.
Innovation.
After spending the week with the Australians, I believe that. I think in terms of adoption in the UK and Europe, we're spreadsheet farmers now. Good farmers are doing their data analytics. They know their costs. They know what it costs per head to pick. They know where it needs to be. It's quite simple. If you can do the same job for a lower price, it will be adopted and it will be bought. There's an element of trying to de-risk the huge amounts of capex that's needed to get some of these technologies into the field. It's something our business really believes there is a place for a service model. So say, let's take a head of iceberg lettuce. Let's say it takes 8 cents to harvest that. If we can come and do it for 7 as a service, great, we've got a business model. That's the way to de-risk it. Long term, we're hearing in Europe anyway, growers still want to own the equipment. They still want to be in control of that. They don't want to be fighting another farmer for using it at the same day. So I think it's a great way to do the adoption, the systems integration, to do these service providers. I know there are a few Californian businesses that have done that on the fruit side as well, quite successfully, some and some. So it's look at innovative technology, but also innovative business models and ways to get it onto farm.
I think in California, weeding and thinning has been quickly adopted, those technologies. The spray technology is pretty exciting, I think, from my perspective, because you've already heard me talk about pesticides. But I do think, in a lot of ways, the hook grower is responsible for their own pesticide applications. They're really jumping on this kind of technology, but the service model is still huge in terms of pest control. And so I really do think our pest control companies need to rework their model. It's probably not any big secret, but money is made on pesticides. So if we really want to reduce the pesticide use using technology, we got to rework the way that the model is. So that is a change that needs to happen. And I really appreciate what you said about harvesting. I think it's not going to look like this holy grail one piece of equipment, but more of these kind of compartmentalized pieces that different people can use. Whether it's nice when you've got a facility and you're inside, but palletizing product. There's like some great little robots that can do that kind of thing. I'd love to see that move out into the field. And my prior work was in labor compliance too, so I think about ergonomics a lot, and I think about workers' comp and how expensive people can be, and how we really don't want to be an industry where we know that we're working people until they're broken, essentially. So anything that can help people do their jobs more efficiently and safer is a win too for the industry.
Yeah, I agree. And our 45 minutes has gone very quickly. We have a couple minutes left for some questions. So does anyone have a question? And raise your hand, and someone will bring a microphone around.
Yeah, I think, from an operator standpoint, we have lots of ways to collect the data and get information, but one of the things really lacking is, I think, the APIs, a common portal, a common, dashboard to really run all this stuff. Otherwise, you're looking at 6 different ways to access the data and actually turn it into actions. How do you guys see that landscape and getting to a point where it is really very user-friendly, so you're not seeing all the behind the stuff, you don't have to go into 6 different systems to measure the 6 different inputs you have?
Well, I think we haven't really said anything to the big OEMs, the John Deere's of the world. I'm sure they're here somewhere. They've really got a lot of that stuff right. They've got the scale and the resource to get these API inputs and to put it into a lovely user interface that is accessible for our operations center or whatever it is. So I think there needs to be better industry-wide standardization at an international level, so that cross-integration of systems becomes easier. I would have said, if I was sat here 2 years ago, the attitudes of the big manufacturers need to change, and I think they really have. So I think there is a way we can start to integrate these different systems in. Standardization would be my answer to that one.
Anyone else?
had a quick question in regards to data. So David, you described a lot of real-time data that you're getting off of your equipment or sensors. What kind of management decisions are you making from that data, and what is the timeliness of that?
So yeah, in our situation, moisture levels, dendrometers on the plant, so the plant is actually trying to suck, so you know you really haven't got enough moisture there. It's easy. My guys rewrite the program to start a little bit earlier based on that moisture, that temperature, the humidity, all that. So we're learning all the time. So our set point will change. And so that real-time data has made us sort of, okay, holy shit moment, so but we get there fast, but next time there won't be one because we've just moved the point ahead of before the trigger happened. So yeah, and the prediction models, again, they're only predictions and they're only as good as all the experiences we have. But without that live data, it gets to a point where you fell off the cliff already and then you're trying to climb back up. So what we're trying to do is not fall off the cliff, but keep that trajectory.
Thank you.
Anyone else? All right, well, thank you very much. It was great to hear about what's happening around the world, and also encouraging to hear that we are all on the same path and have the same goals. And I think that opens the door to a lot of future collaboration as well. So thank you all.